Hello, this is Mr. Huff, and I just wanted to run through some of the presentations we've gone over in class, just to make sure we're all on the same page. We're going to start with metals, and here you can see that we have the properties of metals. Things you need to know is that they are good conductors. All except one, which is mercury, are solids at room temperature. They are reflective and shiny. That property is called luster. They are malleable. The word malleable literally comes from the word hammer, so that means you can hammer them into thin sheets. And ductile, that means they can be drawn into wires. Metals on the periodic table, when you look at that, everything you see here in blue is a metal. So everything left of the metalloids, let's see if we can point those out right here. Everything left of the metalloids here is a metal, with the important exception of hydrogen. Hydrogen is a non-metal. When metals bond with nonmetals, they get rid of electrons or gain electrons. Normally the metal will get rid of the electron and the nonmetal will gain the electron, and they are held together by the difference in their new charges. The positive and the negative charge are attracting one another. This is called an ionic bond. The other kind of bonding that metals can do is called a metallic bond, and it works a little bit differently. A metal atom has a lot of free electrons, or electrons that are not tightly bound to the nucleus, that are free to move from one atom to another. And this, the negative charges pulling against the positive charges causes them to kind of stick together. So as you can see here, we will see an electron C. I like this word here, electron C. So what that means is we have all of the space in between these atoms is full of electrons that love to just move around easily. Because of this electrostatic pull on one another, that makes metals malleable. When you smash them with the hammer, they stretch out, but they're still pulling against each other. They don't want to separate, and that's how malleability works. The first group we're going to talk about is group 1. So you can see the first column: lithium, sodium, potassium, rubidium, cesium, and francium. These are the alkali metals. They have one electron in their outer shell, and that's what it tells us when we see them in column 1. They are good conductors. They're very soft. You can cut them with a pocket knife. And they are extremely reactive. In class, we watched some videos about dropping these metals in water, and you can see that they set on fire and all the way up to exploding. And this slide is just saying they like to give away that electron to become stable. So they normally exist as a positive ion. They have one less electron than they should. And they like to bond ionically. And this is just saying that francium is rare. There's just a few grams of it on Earth at any time, and it's also radioactive. Alkaline earth metals is column 2. This means that they have 2 electrons in their outer shell. And they also like to bond ionically. Magnesium, we talked about this in class. Magnesium is an alkaline earth metal, and it's often used with other metals to make really light, really strong metal. You see that in ladders and baseball bats and softball bats, but you also see it in bicycles, like the video we watched in class. And also, magnesium burns very, very bright white, so it's often used in fireworks. So when you see the fireworks that are those brilliant white fireworks, that's magnesium. Calcium is an element that exists in your bones to make them strong. If you have a calcium deficiency, often your bones are weak. And some other alkaline earth metals are barium, and they use this because in medicine because it responds to x-rays, so you can drink barium and they can see anywhere that barium goes in your body. Radium is a radioactive element, and this was really explored by Marie Curie. She won 2 Nobel Prizes for her work there, and we've talked about that in class, that her Notebooks are so radioactive, they're dangerous to be around. The transition elements are in the groups 3 through 12. These are all metals. And what does it say here? They frequently occur as pure elements in nature, like gold and silver can be found in pure states. And they cause things like the last thing on here is gems. If you look at gems, they are brightly colored. For instance, emerald is a chromium gem, and that's why it's green. We talked about the iron triad. These three metals, iron, cobalt, and nickel, are used to make steel alloys that are very strong. And iron out of these three is most widely used. We have the coinage metals, which are copper and silver and gold. And these have been used to make coins throughout history. Copper is also used in electrical wiring, and gold, is used to make jewelry. Zinc, cadmium, and mercury. It's interesting to think about zinc and cadmium. They use these to coat other metals like steel to protect it from rusting. The inner transition metals are the two rows at the very bottom of your periodic table. They separate those out to make the periodic table a little more condensed. There are a couple of names here. The lanthanide series is the one on top, and the actinides are on the bottom. All of the actinides are both man-made, and they are radioactive. And that's all I have to say about metals.